Imagine a colossal symphony played by a boundless number of stars, planets, and moons, all proceeding as a bound-together opening. At any rate, there is one explicit area of this group that has baffled cosmologists for a seriously prolonged stretch of time. Exoplanets are typical planets that exist outside our planetary gathering, hidden away somewhere deep in the Milky Way. You might be surprised to find that among the huge number of galactic objects, there are exoplanets so like Earth that the story goes off in an unexpected direction, particularly like in any science fiction roller coaster. Experts using the James Webb Space Telescope found something amazing from Proxima b, a signal so weird that it moved through educational sections and casual networks. It was named a potential technosignature, an electromagnetic spread so perplexing and meticulously planned that it could show the presence of a high-level civilization. The joint heartbeat of mankind seemed to stop at the pinnacle of a discovery that promised to change our perspective on reality. Might the signal be the certain proof that we are not alone in the universe? And just as quickly as it appeared, the signal evaporated without repeating itself, leaving behind not just overwhelming silence but also a maze of unanswered questions and permeating theories. Was it simply a transient cosmic anomaly, a mishap of godly arrangement, or something more deliberate, a coded message or a signal from a disturbing cosmic core? The solitary mission cast a shadow of uncertainty over Proxima b, sparking a heated debate in theoretical circles. Was it merely a passing inconsistency, or is it part of an endless record far more baffling than we can imagine? Nevertheless, the record, a woven masterpiece of our boundless exploration, isn't complete. The ink has not yet dried and new chapters are still being written. This time, it's not just scientists but Harvard experts who are leading a change in perspective in our search for extraterrestrial life. They aren't simply analyzing the signals and characteristics we've studied up until now. They are expanding the game by transforming the James Webb Space Telescope into a sort of massive night vision telescope. They want to search for artificial light sources in both the faint and illuminated areas of distant worlds. We're now looking into ideas like distinguishing natural variations of metropolitan regions shimmering in the darkness like brilliant specks. Imagine seeing the radiant beams of what could be a city, humming with the presence of an advanced civilization, sending its glow across vast cosmic oceans. As we continue to unravel the secrets of the universe, the search for extraterrestrial life takes on new perspectives beyond the brief intrigue in Proxima b. Our grand chase dives deeper into the colossal, strange expanses of space. This pursuit is driven by creative advancements and a deep curiosity about our place in the universe. Continuous advancements in cosmology and space exploration have led to the discovery of various exoplanets with potential habitability. Instruments like the James Webb Space Telescope (JWST) and ground-based observatories have expanded our ability to recognize and analyze these distant worlds. One particularly fascinating field of study is the search for biosignatures of life. Biosignature imprints could include atmospheric gases like methane or carbon dioxide, which under the right conditions could suggest biological cycles. The JWST's capabilities go beyond basic discovery. Its high-level instruments can measure the atmospheric composition of exoplanets with incredible precision. By exploring starlight that filters through an exoplanet's atmosphere, specialists can recognize chemical markers typical of life. For instance, the presence of water vapor along with other key molecules like oxygen or ozone could indicate the potential for life-supporting conditions. Another avenue of investigation involves analyzing the conditions of these distant worlds. Environmental models, aside from the possibility of technosignatures, have gained traction. These are indications of advanced civilizations detectable through artificial structures or advanced technology. This could include megastructures like Dyson spheres, hypothetical constructs designed to capture a star's energy, or unusual patterns in radio transmissions. As we refine our observational techniques, the search for technosignatures could reveal the presence of extraterrestrial intelligence. Alongside innovative progress, global collaborations are essential in the quest for extraterrestrial life. Cooperation between space agencies, research institutions, and private organizations enhances our ability to explore space. For instance, missions to Mars and other celestial bodies involve contributions from various countries, pooling resources and expertise to achieve shared goals. Public engagement and education play crucial roles in this journey, and the excitement surrounding space exploration inspires future scientists and experts. Outreach programs and educational initiatives help cultivate interest in STEM fields and encourage young people to pursue careers in space science. The development of new technologies also shapes how we understand the universe. Advances in telescope design, data processing, and computational models improve our ability to recognize and analyze distant exoplanets. Cutting-edge space telescopes like the Extremely Large Telescope (ELT) and the Habitable Exoplanet Observatory (HABEX) promise to offer significantly more detailed observations and deeper insights into the potential habitability of exoplanets. As we push the boundaries of our knowledge, each discovery prompts new questions and areas for exploration. The search for extraterrestrial life isn't just about finding alien civilizations but also about understanding the origins and potential diversity of life in the universe. It challenges our perceptions and expands how we might interpret what it means to be alive. The exploration of exoplanets and the search for extraterrestrial life are dynamic and evolving fields. With each step, we edge closer to answering some of the most important questions humanity has ever asked. As we continue to explore the universe, the opportunities for finding new forms of life and understanding our place in the cosmos remain endless. Tantalizingly similar yet bafflingly different, Proxima b might be our planet's heavenly twin. Found just 4.2 light-years away, the James Webb Space Telescope has shaped our journey toward understanding these celestial puzzles. Imagine a moment when your mind travels across the vast expanse of our galaxy, the Milky Way, which is home to more than a quadrillion exoplanets. That's one followed by 15 zeros. To put this number in context, if each of these exoplanets were the size of a grain of sand, we wouldn't just fill the Grand Canyon. We'd have enough to create another landmark on Earth, a Grand Canyon 2.0 that would stretch for a vast distance. What's most surprising is that around 20% of these celestial bodies have been deemed Earth-like in terms of geological and environmental design. That means there's a 1 in 5 chance of finding a twin of our planet. And the story doesn't end there. Alongside these planets, there could be another quadrillion moons, rough satellites like our moon, engaged in gravitational dance with their parent planets. If you somehow manage to find another body in space that harbors life or potentially could, the universe offers a flood of opportunities. Now that we have laid out the vast scope of the material, it's time to introduce the expert tasked with painting its intricate details, the James Webb Space Telescope. This celestial Sherlock Holmes, with its glorious central lens displaced by movable focal points, outperforms even the most advanced optics. We're not just talking about any lens, its 6.5-meter primary mirrors are 2.7 times larger than Hubble's. Imagine the detail it can detect. Even the faintest flicker of a star billions of light-years away, analyzing the details of orbiting planets. What makes the James Webb Space Telescope revolutionary isn't just its observing power but also its cutting-edge technology, including advanced sensors and spectrographs. These instruments do much more than observe. They analyze and filter the unique light signatures emitted or reflected by celestial objects to decipher their atmospheric conditions, composition, and even mass. Acting as a space detective, the telescope can determine whether a planet has water, organic compounds, or even oxygen. The James Webb Space Telescope has the potential to answer these questions, elevating it from a simple observer to a scientific genius. It represents more than just an evolution over its predecessor, Hubble. It's more like a quantum leap. If Hubble's discoveries amazed you, prepare for an explosion of celestial revelations. As we extend our view across the complex landscape of the universe, it's worth focusing on one specific star in this vast show, Proxima b. Since its discovery in 2016, this strange planet has stood out like a Shakespearean legend, filled with complexity and puzzles, captivating space experts and astrobiologists alike. So what's all the fuss about? Proxima b is essentially in our astronomical neighborhood, just 4.2 light-years from Earth. To put it into perspective, if you could travel at the speed of light, you'd arrive in barely 4 years. About the same amount of time it takes for your favorite TV show to fall into reruns. But let's delve deeper into why this proximity is so significant. We're talking about a universe that spans over 93 billion light-years from one end to the other, so finding a planet so close and so promising for scientific exploration is like finding a diamond in a mountain-sized pile of rocks. A gem that could hold secrets about life itself. In the grand tapestry of the universe, Proxima b offers us precious clues that could redefine how we understand habitability and life beyond Earth. It's not just Proxima b's proximity that excites mainstream scientists but also the tantalizing signs that this planet isn't just Earth-like but maybe even Earth 2.0. Proxima b sits in what space specialists call the habitable zone of its parent star, where conditions are neither too hot nor too cold, just right for liquid water to exist. Imagine waterfalls, meandering streams, vast lakes, and perhaps oceans as deep and mysterious as the Mariana Trench. But before we start dreaming of a visit to Proxima b, we must consider some of its peculiarities. For example, a single day on this charming exoplanet lasts an astounding 11 Earth days. Imagine sunsets that stretch into another day, slowly resisting the arrival of noon, and dusks that linger, creating those golden hours photographers dream of. While this sounds idyllic, it also has significant implications for temperature changes, wind patterns, and seasons. Proxima b also has an unusually active sun, Proxima Centauri, a red dwarf that flares with energy more often than the sun we know. Its frequent stellar storms could either spell disaster for potential life or serve as an engine for evolutionary diversity, forcing organisms to adapt to harsh conditions. The discovery of Proxima b has pushed us to reimagine what we know about celestial worlds. In the grand mystery of the universe, we've only just begun to scratch the surface of what Proxima b might reveal. With instruments like the James Webb Space Telescope, we are more equipped than ever to answer one of humanity's oldest questions. Are we truly alone, or is there another world out there teeming with life, waiting for us to uncover its secrets? In summary, the search for extraterrestrial life and the exploration of exoplanets continue to intrigue humanity. Advances in technology and collaboration among researchers bring us closer to understanding the nature of these distant worlds.